Hey, this is René. In this video, I want to talk about the Python integration for MetaTrader 5, and I want to show you a program that I wrote that builds a Python socket and a MetaTrader socket, so server-client connection, so we can transfer data from a Python program to the MetaTrader and from the MetaTrader to the Python program. So a quick demonstration here. Let me run the program here. So I set it up so that the Python program is working as a server. So this program is running now. This is the Python program. And then in the MetaTrader, I have a program, I need to find it, which works as a client. And we use the Windows library for networking, or the Windows socket library. So if I click on OK here, we can see these two programs then connect via a stream. So both create a socket, and then there's a stream in between. So we can read a direction from one side, or we can send messages from the MetaTrader to the Python program, and we can also send messages from the Python program to the MetaTrader. So here you can see in the Python program, we are now printing the current price of the program where I activated this. So all the ticks are coming in here in the Python program, and we could process them. And every X seconds, I think 3 seconds here, the Python program is also sending a message to the MetaTrader, and the MetaTrader can then read the messages and print them. Also, a little disclaimer in the beginning, because at this point I'm definitely not an expert on networking. I'm also not an expert on Python. I learned Python like a week ago. So this is why my knowledge here is definitely limited. Still, this program is running, and like the basic logic, I mean, I wrote it and I understood how the implementation works, even though I don't want to say that I know how the Windows socket library works.
This video is presented by BM Trading. Learn to code your own expert advisors. Link in the description.
So first of all, let's have a look at the Python code for this. So this is not by any means a Python tutorial or anything. I think I'm not the right person to do a Python tutorial. If you're interested to learn the Python basics, you can find a lot of tutorials on YouTube. I also learned it with a YouTube tutorial last week. So what we do here is we import a few of these Python libraries or packages. We import socket, threading, and time. So with these three imports, or especially with the socket import here, we can then, I will talk about the functions here later, but then we can create a server socket here. And I decided to create the server in the Python script. So we say server is equal to socket. This is just the name for the import here, and then we call the socket function. The socket function here, it takes two parameters, which I think defines like how the socket is built and the protocol that we want to use, like UDP or TCP. And then afterwards, we can call the server variable here to bind this socket at to a specific address, and the address here is the 127.0.0.1, which is the local host, so the local machine that we are using. And then we have to set a port. A port should be, of course, greater than, I think like the first 1,000 something ports are usually reserved for Windows specific tasks. But then if you pick any higher number like 8888, there's a high possibility that this port is free. And this is requested as a so-called tuple or tuple. I don't know the pronunciation, which is something that I learned when I had a look at Python, and it's pretty similar to an array, but you cannot modify it. This is my understanding so far. And here we call then server.listen to wait for new client connections. We take, this is a, I think it's called backlog, and this means that we wait, or we accept 10 failed connections before we do not accept any more connections. I think, yeah, this is not like super important because we are working on the local machine only, but yeah, we can just set a value like 10. So this sets up our server socket in the Python environment. And at this point, we are ready with this server socket to listen for connections. And this is what we want to do next. Here we say while true. So this is also a loop that we will never break out of. And here we say a connection and address, which is again a tuple is equal to server.accept. Yeah, and this accept function will return a new socket, which we can then use to read, send or receive values or data from the stream that we created here. And yeah, the other parameter is the address, I think. I don't really know how this is calculated or interpreted, but yeah. And then what I did here is I created 2 threads because I wanted to create a program or a server that is able to read and write to the stream at the same time. So we want to receive messages and also we want to send messages at the same time pretty much. So what we create here is a thread for reading first, and here we use the threading package called the thread class here, and we say the target of this thread is our read function. The arguments are the connection and the address that we just received here or initialized here after accepting the connection. Then we say thread read is a daemon. And I just realized that we don't really need it here. What this means is that this thread is not keeping the program alive, so to say. So if we have more threads running and every thread that is not a daemon is terminates or finishes, then the program finishes. But since I erased this part of the code, I don't really need this anymore because we don't really stop the Python program like in a normal way. I just let it crash or end it by closing the Python program, which is pretty much not the best programming habit, I think. And again, this is not a recommendation. I'm not a Python pro, but the program works like this. And what we then do is we start the reading thread, and here we create the writing thread, and so we also start the writing thread. The writing thread target is the write function, and the arguments are the same. So what is threading? Threading helps us to have multiple tasks in the same Python script and they are executed at the same time. So usually Python programs or Python code is processed from top to bottom, but if we create threads, this will help us to create or to run these threads at the same time. So if we say here, for example, we create a thread and we start this thread, then the program code does not stop here until the thread is finished, but instead we also process the rest of the code already. So how do these read and write functions look like? I have the definition for these functions up here. So the read function has one loop here, which is wrapped in a try except block. So we try to execute this, and if we have any exception here, then we will enter the except block. And what we try here is, while true, which means that we always do this pretty much, we try to receive a message from this connection here. And remember, the connection is passed as a parameter, and it is the socket pretty much that was created down here when we accepted a new connection. So we use this connection socket to receive data from the stream that we just connected to, and then we store the data in a message variable. Next, we check if message is not blank or not empty, because if we try to receive messages from a stream and the stream is active, but it does not have new information for us, then the message variable will be filled with a blank string pretty much. So we check if there is a string with actual values in this message, then we want to print this string, which will be the information that was sent to us from the client program that connected to our server here. And if we fail to receive data from the connection, it usually means that the client stopped or terminated the connection, stopped working, or was sending some data that we cannot process or whatever. So if we have a connection error, this is what I'm looking for here, then we say thread lost connection to address. And this is actually the point when we also stop the while loop, because if we have an exception here in this try block, we will enter the except block, and then we will print this and we will leave the thread. Same procedure is applied here for the write function, which is also called called by the thread or another thread. And here we also have the connection and the address. And what we do here is we do pretty much exactly the same. The only difference is that instead of reading from the stream, we send a information to the client. And here we always just send some text like, oh, you sent something, thanks. This was my idea. You could write whatever you want here. And afterwards, we call the time.sleep function to just wait for 3 seconds. We can only use this because we imported the time package up here. So this is pretty much the Python program. So we have the necessary imports up here. Then we have 2 functions that we created that we want to use in our threads. Then we create the server socket here. We define what protocol we use and some more parameters. Don't ask me about the details here. And then we bind it to the local host, so we know that we are working on the local machine. We add a port. So this is also the port that the client will use then. And then we start listening to incoming connections. And this is what we then also do in the while loop here. So here we always accept new connections and store the new connection socket and the address of this connection in 2 variables inside of a tuple. And then we have a print message, and then we start the threads for this new connection. And that's the Python code. So as I said, I'm not a Python pro. Like for some of this stuff, I don't know exactly how it works. So let me know in the comments if my explanation was still good enough for you to understand it. Then let's go. Oh, also, of course, you can only do all of this stuff if you installed Python on your program. So make sure to install Python before you want to write Python code. Also, the integrated development environment that I use, or the development environment that I use, is PyCharm. You can also download it for free in the internet. Also, it would be a good programming habit to close the connections here, like this connection, the server connection. I just commented this code out of my script because, as I said, I do not end this script in a normal way anyways. So it does not really matter if I close the connection, because if the script is ends or is terminated, I think the connection will be closed automatically. So that's the Python part. So let's go to the MetaTrader now. The MetaTrader part for me personally was harder to understand, I will try to explain it to you. So first of all, we have 2 options pretty much to work with sockets in the MetaTrader. First of all, we can use the socket functions that we have in the MQL5 framework. You can find these functions and read about them in the documentation of the programming language. And actually, these functions are very good and they are super easy to understand, and you can create a client socket very easily using these functions. There are some problems. Like for me, for example, I was not able to actually receive data with this socket. whenever I tried it, I was able to receive one message, and then for some reason the connection was broken. I don't know why. If it's a bug in the MQL5 functions, or if I just messed up, but I was not able to do this. Also, the second very huge limitation is that these functions do not work in the strategy tester, and this is for me even the more important limitation. So instead of using the native MQL5 socket functions, instead you can use the Windows library, which is the Win32 sock whatever library. And this is even more complex than the Python code. So the problem is that this Windows networking API that we have to use, it uses a lot of macros, and it uses a lot of specific terms that are very specific to Windows coding. And if you are not a Windows coder, and if you do not do this on a regular basis, like I don't do it on a regular basis, so a lot of these terms will not really make a lot of sense for you. But just to make it very, very short, all of these specific terminologies like byte word, D word, PTR, whatever, this is usually just another word or a specific data type for some of the simple data types that we usually use in MetaTrader programming also. And if there's someone who has a lot of experience with Windows programming, and he will probably think that everything I say right now is not really correct, but this is how I explain it to myself. And I think this is also what makes a lot of sense to me. Like all of these Windows specific terms, they're often just another term for the simple data types. And then also you have a lot of constants and defines in the Windows library, I think. But long story short, if you want to learn about Windows networking, you will also find for this very good tutorials in the internet. Also on YouTube, I watched a tutorial about Windows networking to not get a deep understanding, but at least get a basic understanding. And this is very good to get a basic understanding. Then we could create our own file, or we could include all of the Windows library functions, etc., ourselves. But this is not really necessary because there are existing solutions for this already. Like here, for example, there are actually 2 MQL5 forum threads that I read that helped me a lot with this Windows socket library and how to use it in the MetaTrader. And the original author in the forum was Alexei Sergeev. I don't know how to pronounce it, but credits to him because he created this file pretty much, which helps us to just use the Windows socket library without creating all of this code on our own. I think I will be able to put this in a Git repository and link it below this video in a comment so you can easily download it. And I don't want to go into detail here about this specific file because, to be honest, most of the stuff I don't understand it. But still, I'm able to create this client socket connection because this is a great thing about programming. We don't have to understand all of this more complex, more low-level stuff if we just use if we just import it from a already existing solution. So what I did instead is I wrote this test client socket.mqh file, and what I did here as a very first step, I just included the socket lib.mqh file, which is the file that I just talked about and that you will get from my then Git repository if you want. What I did here is at the top, I defined the server IP address that I want to connect to and the server port, which of course have to be the same values that we use in the Python script. So the localhost IP address and the server port of 8888. Then I create this socket 64 client here, which I initialize with invalid socket 64. And I know, super confusing stuff, because this is not normal in MQL5 programming. But if we have a look at this, for example, all of this stuff, as I said before, it's really defined here in this file. And for example, this invalid socket, and these are just definitions for constant values most of the time. So if you're interested to learn more about this, read yourself through this socket lib.mqh file. But if you just want to get your program up and running, you can just copy the steps that I did here in my tutorial or in my video here. So I create this client socket, and then on init is not really necessary. You can call the onTick here, but you don't have to. Then in the onDinit, we call the close clean function, which I can explain here in the beginning already. The close clean function, it just helps us to close any existing sockets. So if our socket, which is the client socket here, again, this is this global variable at the very top. So we check in the close clean function, we just check if this client is currently a valid socket. So if it is not invalid socket, then we want to close the socket. And the close socket function, again, you will find it in the socket lib.mqh file. So we just close this client socket, and then we will set the client variable again to invalid socket 64. Then we also call the VSA cleanup function, which is part of the native Windows socket library. This will do the cleanup process. Again, I don't know how exactly this works. I think most people who are not working with the Windows library frequently, most people do not know how it works, but still we can use it without understanding all of the deep logic that we would have to learn if we were a Windows programmer. And then we just say socket closed. So this is what we do in the onDinit. Then in the onTick function, we have a if statement here. So first of all, we check if our client socket, this one here, if it is unequal invalid socket, which means that it is a valid socket. So if we enter this part of the if statement, it means pretty much that our socket was able to connect to another server socket to create this stream. But if we do not have a valid socket, then first of all, we process this block. And what we do here is, first of all, we will have to create the client socket that then tries to connect to the server socket. And then we will have a beautiful connection, and we can stream data from left to right and from right to left pretty much. So what we do here is, this is a lot of the Windows stuff. So again, I can only recommend, there are multiple good videos, I think, on YouTube that you can learn with. I watched a video by some guy, and he explained how the Windows networking library in general works and how you can create sockets. So what we do here is, and I think WSA is always just short for Windows Socket API. So we have the we have a character array here, and then we have to and this with a data is a structure. So in this array here, we will store a lot of information about the connection that we then, we start the WSA, like the Windows API for sockets. So we first of all start this. This will create or start some Windows processes in the background, I think. Again, this is not super important for us, but it is the first step whenever you want to work with a Windows Socket API. Then we check if we were successful in doing so, in starting this API. Then we can go further and create our client socket. So this socket can be created using the socket function. Again, this is not native MQL5, not a native MQL5 function, but you will find it in this socket library file. And here again, this is very similar to what we did in Python. Like, remember, we said here like what kind of internet protocol we use, what kind of socket we want to create, and this is pretty much what we also do here. So it's the same. I think this is the internet protocol, then the same like streaming protocol like TCP. And yeah, also it's a socket for streaming. And then we check if we were able to create this socket. If we were not able, we print an error message and we close clean. But if we were able to create this socket on the client side, then we want to connect to the server. So first of all, we will have to specify what the address of this server is. So this will be requested as a character array. So a character array is pretty much just a string, but every letter of this string is as a character, which is a like one specific letter or number or whatever. And this is, so we have to transform our IP address, which is like local host or 127 whatever. We will have to turn this into a character array. This can be done using the string to character array function. Then we create the socket address in. I think it's a structure again, which we call address in. And this structure has different variables which we then have to set. So here again, this is this internet protocol. Then we will have the internet address, which is our character array, and like the local host or 127 blah blah blah. And then here we have the port. And you can see often in the Windows library, if we work with the Windows library, we do not just take like the character array or the port, but we have some helper functions to transform the data a bit. Like if we have a look at this htons, oh yeah, it is just a function actually that we get right from the Windows socket library. So I cannot explain what exactly this does, but it takes our host. This is like the port, I think, and it transforms it in some way that the Windows library expects the data to be in this specific format or type. And also same with the character array here for our internet address. It will also be transformed to an unsigned integer, and this is then what the Windows library is happy to receive. And then, yeah, we create another ref sock address variable here, which we call ref. And then this is one important step, like the sock address has to be transformed to a ref sock address. I don't know how this works. It's pretty complicated, I think. Or, I mean, I would have to look it up. Maybe it's not that complicated. But also, I just found it in the forum, in the MQL5 forum, like in these two articles here in the MQL5 forum. These entries really helped me to understand the file that I use here. And I highly recommend working with these and reading these articles. I can also link them below the video in a comment if you're interested. So we turn this socket to a ref socket, and then we can call the connect function. Again, you can find it in the socklib.mqh file to use our client and to connect to this ref address. And yeah, also we need to provide the size of the address or the address in variable here, which is the sock address in structure. Then next we check if we were able to connect, and this is actually when the client socket sends the connection request to the server, and the server will then here, like the Python server, at this point will see that the client tries to connect and then accept this message. But yeah, after this message or the connection was accepted here, then we can also set to non-blocking mode. I don't really know what this does, to be honest, but this is what I also found in this article in the MQL5 forum. And yeah, that's pretty much it. So this is all of the piece of code that we do if we do not have a valid socket. So we just try to connect to the server socket. But then afterwards, our client socket will be connected to this server socket. And since this client is a global variable, this will not lose its value. So the next onTick function will then realize that the client now connected or is a valid socket. And then what we want to do here is we want to send the data to the server socket, the Python program. And then what we want to do here is we want to send the data to the server socket, the Python program. And then what we want to do here is we want to send the data to the server socket, the Python program. And then what we want to do here is we want to send the data to the server socket, the Python program. And then what we want to do here is we want to send the data to the server socket, the Python program. So here we create a character array, which is the data. We put whatever information we want to send to the server using the string to character array into this character array. Here I just send the current bit price of the current symbol. And then we use the send function, which we can also find in the socket lib.mqh file, to send the data using our client socket. Then we send the data here, the data array, and we have to provide the size or the information amount that we want to send. And here it's array size data -1. This -1 can be added because if you turn a string to a character, at the very end you will also have 1 byte for a escape character, and this one is not really necessary to be sent to the server. And the last parameter here is the flags. Yeah, we don't have specific flags, so we just send this information to the server, and then we can check if this send operation failed. If it failed, we send a error message to the experts log of the MetaTrader, and then we call the close clean again. But if it was successful, we print also to the experts journal of the MetaTrader, and we say we send symbol tick to the server. Then also, since the server here, the Python scripts, every 3 seconds it sends a information to the client. That's why we also have to receive information from the server. And we can do it like this. We create a buffer with a specific size. And by the way, it is important to define the size here. If you forgot this, it will not work. So we set a size here for the buffer. So we can accept a maximum amount of 1024 characters, I think. And then we say if receive, and this is again a function to receive data from a stream, and it is defined in the socket lib.mqh file. Here we use our client socket again to receive data, which should be stored in this buffer, and here we have to provide the buffer size again. Then again, we check if this was successful. If it was successful, we print something. If not, we call this error message. And that's pretty much it. So if you compile this program for the client in the MetaTrader, then you should be able to run your Python script on your PC. Here you can see Python script is running. It's currently waiting for connections. And then you can go to your MetaTrader and run the program that you wrote here. Here, realize that we have the dependency. These are all the functions that we have in the socket lib.mqh file, where we import the Windows native socket API. And yeah, so this is what we use here. So if we click on OK, you can see we connected to the server, and then we send the ticks to the server, and the server is receiving the ticks. Also, the server every 3 seconds is sending a nice thank you message to the MetaTrader. And this message is then also printed in the MetaTrader. And yeah, as I said, the formatting is a bit off here because we do this on every tick, and the messages are sent, like if you have less than 1 tick, for example, every 3 seconds, then you will receive multiple messages coming from the server at the same time, which will kind of look a bit messed up. But yeah, you could of course handle this in the MetaTrader program by just adding some logic to use the buffer correctly. But yeah, this is how you can do it. Also, I want to show you one more cool thing. Like if we, for example, like if we close this, you can see now we lost connection, or Python script lost connection to the socket, or to this MetaTrader socket. So now we are waiting again for a connection. And I want to show you one more very cool thing. So if in my MetaTrader I now open the tester, and here in my MetaTrader tester I now use the test client socket program. So the same program that I used in my live chart a second ago, I will now use this program in the tester. And you will see that it also works in the tester. And this is so cool. So let me open this. So here you can see tester is loading, and let's also observe here. Oh, we already established a connection. Whoa, and you can see the ticks are coming in very quickly because of course in the server, the ticks are generated quicker than in the live chart usually. And you can see now the tester is sending the information to the server here, which is very, very cool. And the server is receiving the information and it's also sending this message like, oh, thank you to the tester or to the client socket, which is now in the tester. So this is very, very cool, I think. So let's delete this program and let's close also the program in PyCharm here, the Python program, because I want to show you one last thing. Since MetaTrader 5 is now capable of executing Python programs, you can also go ahead and put this Python program into your MetaTrader. Like here, for example, if we go to scripts, well, you will see I also have the test server socket Python script here, which is pretty much the same program, but it's just in the MetaTrader. So if you save it here, I think you don't really have to compile it because Python is a script language. And then you can go to your MetaTrader, and here in the MetaTrader, and this is very, very cool, I think, you can go ahead and let's, for example, yeah, let's maybe, let's open another chart here. US dollar, for example, chart window. Let's say on US dollar chart, I now want to put this test server socket program. So this is the Python program, but no, it is not running in PyCharm. So I can close PyCharm. I don't have the PowerShell of Windows open, but I run this Python script in the MetaTrader itself. And then also on the other chart, I can run this test client program again to create the client socket. And if I click on OK, so you can see this also works. And now the server socket, which is running in the MetaTrader pretty much, and the client socket, which is also running in the MetaTrader, they are now talking with each other. So the ticks are sent to the Python program, and the message that's coming back is received and also printed here. So this is so cool. So yeah, this was my little explanation of my first attempt to write establish a connection between a Python program and a Windows or MetaTrader program. Yeah, as I said, I'm not an expert in many of the fields I just talked about. So if this was a real pain to watch, let me know in the comments. But if you appreciate it, also let me know in the comment, because I can work myself deeper into the field of Python programming for MetaTrader, and if you're interested, I can provide some more useful videos. Also, I mean, what this could be useful for, I forgot to talk about this. You are able to also send operations, like buy and sell operations and stuff, from your Python program itself. So theoretically, you would not have to use a MetaTrader program at all, but the Python scripts are very limited, in my opinion, because you cannot use them in the strategy tester. Also, writing code that executes or that uses the MetaTrader package in Python, in my opinion, it is overly complicated compared to the native MetaTrader 5 programming language, MQL5. Also, MQL5 code will be, of course, a lot more efficient and quicker than the Python script. You might still want to use a Python script if you, for example, have to do AI or machine learning stuff. So if you want to use any AI machine learning libraries, which are, I think, usually Python libraries or packages, then you maybe want to use a base program that you wrote in MetaTrader 5 language, MQL5, and then in this program you just occasionally want to use or call a function in the Python script, like some machine learning function, for example, and then just want to send it to the Python script and then want to get the feedback from the Python script, and then the rest is done again in the MetaTrader program. So this is what I could imagine would be a good use case for this specific program that I just showed you. Because if you have this socket server, socket client connection, you can always pass data back and forth and really have a base MetaTrader 5 program and then still use all of the Python power with especially machine learning stuff. Yeah, and make use of this. So yeah, that's it. So this was my very first Python whatever integration tutorial. Let me know what you think. I appreciate your feedback, and I hope you liked it. Have a great time. I'm out. Bye.